The idea behind this talk is basically to summarize things that I've found when looking at other people's RESTful services. And so like from a pen tester's perspective, these are things that you might want to look at. And if you're a developer, these are the things that you need to look at when building a RESTful service. So just quickly, who am I? I work as a developer and a security guy. I'm also the lead of the OWASP Norway chapter. You have my Twitter handle there as well. So, a puzzler first. What is this? Whose REST API is this? Anyone? Sorry? No, it's actually the Tesla Model S. So you have honk horn. I find that an interesting API point. So you could build apps that actually honk the horn. So that's everyone is using REST APIs these days. You can find them everywhere. You can find them in websites. You can find them in all sorts of apps. And so it's really important that we start looking at the security of these things right now and not later. So there are some rules that the REST guys have made, and they sort of try to build up on HTTP instead of doing everything the SOAP guys did, where everything got really complex. They're trying to like move back to HTTP and the simpler things. So you rely on HTTP verbs like get and put and post and delete. You use all of them, not just get and post like normal web apps do. And you have no server-side state in session. So there should be no session on the server. You use links to map things together. So any resource has a certain URI. You're not building the URIs yourself as a user of the API. You get URLs for everything, and everything should have a URI. So you don't have a user with an ID of 1. You have a user with a URL instead. So that's the unique idea of that user, for instance. And you have no server-side state in session, because that's really important. And you use your own hypermedia format. So instead of saying application JSON, you might say application and something something JSON or something something XML, because you have defined your own format instead of just using XML or just using JSON, and then you can have versioning and things like that. And you have no bloody server state in session. That's important. That's at least what these guys are saying. I tend to not agree all that much with that point, because it's even on Wikipedia that you should not have any session state. And for a server-to-server system, that makes sense. Like the state itself is wrapped in the resource that you're passing back and forth. But if you're using this REST API from a web browser, you need to have some kind of a session where you put is this user logged in or not? When does the session time out? Things like that. And I mean, the direction people are moving now is putting things in signed cookies so you can scale out. But the problem is with signed cookies, there's really no way to log out, because you can delete the cookie, but the cookie is still valid. So if someone has a copy, well, they can still use your server. So I'm not too fond of that actually, but I'll leave that one there. So session timeout, I said, was a problem. Logout, I said, was a problem. What about third-party authentication if you're using like a token-based approach? That's also not that easy if you don't have something on the server that can take care of those things. CSRF tokens, yeah, you could put them in cookies and do like the triple submit cookie or something, but it's still easier to just have them in the session on the server. Next topic for RESTful service is confidentiality. And as I said, when you're doing REST services, you're usually relying on things that's already there. So HTTPS, but make sure you use and harden your TLS config. There are good tools out there for doing that. And that's something I often find it has been forgotten. They've forgotten to harden the config. They've set up a good valid certificate that was expensive with extensive validation, et cetera, but there are still like ciphers that should not be enabled that are still enabled. If you don't want to use that and you're going to use custom encryption, there are so many mistakes that you can make. You heard Jörg Schwenk at the first talk here today mention some of them. You quickly end up making an oracle of some kind, either a timing oracle or a padding oracle of some kind that can be used to break your crypto, or you're using the wrong cipher block mode or something like that. So it's easier to just rely on TLS or SSL. And that's also something, within the REST API, you usually have just 2 servers. In a SOAP-based approach, you can have multiple servers on the way where they're doing different things with the XML message before it's reaching the final destination. But usually in REST services, you have a client and a server, and those are the 2 talking together. So you don't need all this XML signing and things like that. But then again, this is, it depends on the scenario. So authentication. Again, back to the HTTP standards. So people use basic authentication, which is okay if you're on SSL and it's a server-to-server approach. Or there are things like digests, client certificate, NTLM, Espiniego. Or you can use a normal session-based approach like we're doing in web applications. Or we could use like token-based approaches where things like OpenID, SAML, or OAuth 2 with signed tokens. You can't use OAuth as is for authentication, but if you have signed tokens like OpenID Connect, then you can use it for authentication. Then there's authorization. So this is an example of vertical access control. I'm not sure how many card readers there are on this poll. There's quite a few. And this is horizontal access control. The difference is, of course, that vertical access control is role-based. So that, are you an admin, you're allowed to do this. Are you a normal user, you're allowed to do this. But horizontal access control really comes into play here because we need to make sure that only I can edit my own resources. So if let's say the REST API was Facebook, only I should be able to edit my own account, not someone else. So that's an example of horizontal access control, which gets really important, especially when you have a lot of users. They're authenticating, uploading their data, and you don't want to sort of leak that or allow someone else to change your data. Then there's integrity. We need to make sure that data is not somehow changed during transit. So we can use HTTPS. That's the easiest way. Or we could start signing things and using like certificates or some secret key or something like that. And the approach, if we're going to sign something and not going to use HTTPS, is we first need to canonicalize what's going to be signed, which means bringing it down to a basic format that's the same on the client and the server. Then we sign it, and then we encode the signature. And typically in a REST service, you would then encode it as base64 and include it as a header in the authorization header or something that you say this message is signed and here is the signature. And then when you're verifying the signature, you canonicalize the data that you expect it to be signed, you verify the signature, and then you use the canonicalized data. And this last bit is really important. If we look to WS security, or WS Death Star, that some people call it, because the standard grew so big, there were some problems like this there, where they were doing canonicalization, signing things, delivering it over to the server, and the server would check it, and then not use the correct part of the data. So that's often called a signature wrapping attack that you use in XML, where you have a signature, and that signature is valid, and then you inject a new element and move the signed element somewhere else. So when the server tries to validate the signature is there, the element that's signed is still there, but when the code is continuing, it's using different data than the data that was signed. Juraj Zamorovsky is doing a talk tomorrow on WS Attacker, and he's probably going to talk about this there. So that's actually a very interesting attack that we've seen on web services, and that can very quickly happen in a REST API as well, if we're just implementing things on our own and not really using libraries and things like that. And what Juraj and the other guys found was this was a problem in a lot of SAML frameworks, like a sample framework would get an assertion, and it would check, is there a valid signature on this, or I want to validate all signatures on this sample token, and if there is an invalid signature, I'll reject it. But in some sample frameworks, if there was no signature, there was nothing to validate, so it just continue. And on the others, you could do like these wrapping attacks. But it's amazing that you can have a sample token that doesn't have a signature and it's still accepted. So we need to make sure we know what we're doing if we're going to implement this on our own. Yeah, so go see the WS attacker to talk tomorrow. There are other ways of doing this, and one example is Amazon. They're sending the signature as an authorization header, and what they're doing there is they're doing a canonicalization process of the data that you're sending in. So it's quite a bit of code, but what they're doing here is they take the HTTP verb, they do an MD5 of the content, then they're adding the content type, the date, and then they canonicalize some special headers that are just for Amazon. And all of this is concatenated together, and they're doing HMAC SHA-1 on that, UTF-8 encoded. And then they sign that. Then you have a signed value, and you base64 encode that and put that in the header. So that's one way of doing it, but it's quite complex. And you have to, again, you have to know what you're doing, and you have to use the canonicalized data once you get it back, so you don't end up in a situation where what you're using is not the same that you got in. So next up is avoiding replay attacks. Look, if I have a valid message and I don't have any server-side state, I get a message in, which is create a new account, create a new bill, pay a new bill, and everything that's authenticating that message is, if everything is in the request, that request can be replayed, and you'll pay the bills several times. You need some way to avoid replays. And if you don't have any kind of server-side state to make sure that you can detect if you've seen the request before, then there's really nothing you can do. So you can have time-based things, but if the attacker is able to do it in a quickly fashion, then, well, you're on your own. So what you can do, you can use HTTPS, of course, to make sure that they can't really extract the data and replay it. You can use a signed timestamp. Again, there is a window where something will be valid for multiple times, so it's not really the best solution. Or you can have like a global ID, a UUID or a GUID inside of the request that you're doing, and that part is signed, and you keep a list of GUIDs or UUIDs that you've received recently, so you can reject it. And you only, if you have both a signed timestamp and a signed GUID, you only have to maintain this list of UUIDs for as long as the time is valid. Then you can just throw them away. But then you know that you can receive a new one inside the current window. So that's quite easy to do. And you should all know this attack by now. For some reason, it keeps popping up. Denise Cruz and some other security researcher, they were doing a talk now on DEF CON about this attack. And for some reason, this goes away for a while, and then it comes back. And then it goes away for a while, and then it comes back. And it is quite a cool attack. So what we're seeing here is there's a doc type declaration on top of it. It might be difficult for you guys at the back, but you'll get the slides later and you can have a look at it. There is a doc type declaration at the top here, which is defining a new entity for use within the XML. And that entity is pointing to a file on the file server, or on the server that's running the REST API. And then that entity is used down here. So if I now click the send button, I'm sending this XML to an actual server now, and I'm displaying the result down here. It actually, in the body, because the tag was in the body here. So in the body here, and so the secret password is password. But that's not all that interesting, so we can do other stuff as well. For instance, we can read some more interesting files on the server. See? So this is the top of the etc password file on my laptop. It's been put into the XML and echoed back to me. So I can read any file on the server. And I actually found this problem on a REST API I was assessing recently. Luckily for them, they were using an XSD to validate sort of the incoming requests against the schema. And within the schema, they had said that this field can only have 100 characters. So I could only read like 100-byte files, which wasn't really all that useful. So luckily for them, it wasn't the worst scenario that it could be, but still it was worth fixing quite quickly. And you can read any file. You can even read external resources. So you can use this in timing attacks. If you don't get a response back, you can load an external resource and see if that's pinged. You can load an external resource that never returns. So you can use it for DOS. You can use it for all kinds of cool stuff. Jersey, which is a pretty famous Java REST API framework, had this problem. It was in a pre-release version, so it was never in the production version. But still, they had this problem. You should check out Denise and the other guys' talks. There are some links there. You'll get the slides later. You can click them and see, and you can also just search for DEF CON resting. You should find it. It's quite cool what they found. There was also, as far as I understand, an XSE attack in yesterday's CTF. So some of you were probably familiar with this already. The next thing you can do is what's called the entity expansion attack, which is pretty similar. But instead of defining the entity as a file, I'm now recursively defining some entities there. I say that A is 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. And then B is A, and C is B, etc., etc. Can anyone make a guess for how large this XML would be on the server? Just make a guess. Will it be larger or smaller than 100 megabytes? Way larger than 100 megabytes. Will it be larger than, say, 1 gigabyte? It will be larger than 1 gigabyte. It will actually be 687 gigabytes in size. And it's this small thing here grows to 687 gigabytes. That's insane. Luckily, a lot of the REST frameworks, they will look at an incoming request and they will try to expand these things, and they will say, well, a request can only be 200 kilobytes or something, and then they will reject the request. But you can imagine if this was your server, and you could find like the sweet spot where you would actually manage to insert these things, and it will like eat up the memory of the server and just completely DOS it. Here's a demo of that as well, a simpler one, because I don't have 687 gigabytes of RAM on my laptop, so I'll use this one instead. So I'm defining A to be 1 to 0, and then B to be 8 A's and C to be 8 B's. And as you can see, it kind of grows. So, by the way, the server that I'm using here is something you can download afterwards from GitHub and play around with it. So it's a Jersey server where I've gone in and disabled all the XML security stuff, so it's possible to play around with it. So that's something you can do if you want to. If you're going to look at these slides by yourself, you can start this server locally and then open the slides, and the slides will connect to the local server, and then you're on. Then you can do the exact same things that I'm doing right now. Here's another thing. What happens if you do like a lot of XML tags inside each other, like 1 million times inside each other, and you don't have a schema to validate against, and you have like this XML framework that's just like building an object model as it's reading there, and just building like this huge memory model. Again, you can DOS the server, or at least make it go fairly slow. So that's also an interesting attack that might work on some services. So if you're going to do secure XML parsing, disable doc type declarations like the ones that I was using for both the XML entity attacks and expansions, so that they don't work anymore. It's fairly easy in most XML frameworks to disable them. You might not want to use a DOM-based parser because a DOM-based parser will read the data into a memory model before validating it. So you might prefer a SAX-based, just like an event-based handler that can reject things faster without using so much memory. But that depends on where you want to go with it. And you should validate against schemas. As I said, that was actually helping the guys that had the XSE problem, where you can only read like 100 bytes files. So if the file was larger, the request would be rejected and you would get nothing back. And don't use XML decoder if you're doing Java. Again, Denise Cruz has a blog post about this. XML decoder basically allows you to instantiate Java objects and run them. So it's like remote code execution. I don't think XML decoder should ever be used for RESTful interfaces. And check out wsattacks.org, where there are a lot of these attacks described. So if you're building a REST API for a web application, there are some things that you might want to do. You need to transfer data as JSON instead of like doing all sorts of HTML snippets that are inserted into each other. And you should not have any HTML entities. It should be exactly as the data is supposed to be in the JSON, and then you do the escaping on the front end. Because if you don't do that, you might end up in situations where you're not sure if it's HTML or normal text that's coming from the server, and you're either double escaping or not escaping at all. So you should pick one and use that all the time, basically. You should always set the character set so you avoid attacks where data is interpreted as a different character set than it actually was. And you should use, of course, secure defaults for frameworks and functions. Like in jQuery, use text instead of HTML, so you don't insert HTML without intending to. And other kinds of frameworks as well, where you can actually either use secure defaults or turn on security for you, so you don't have to do everything yourself. And you should also come see my talk tomorrow if you're interested in this exact part. I'm doing a talk tomorrow on these kinds of apps where you have a RESTful JSON interface and a JavaScript-based web app on top. So come see that talk if you find this interesting. Caching is also interesting because when we're relying on HTTP, we might end up in situations where we're caching things that we're not supposed to. So a proxy or a client can cache things, but it can also cache things by mistake. And this happened in Norway a few years back, where once a year in Norway we get our tax returns, and everyone goes to this Norwegian government website to see our tax returns. And there was a proxy server sitting in between where there was some kind of weird caching error. So everyone would see the tax return of one specific guy. And he became famous in Norway. He was called Altinn Kenneth. Altinn was the name of the system. And he was interviewed in newspapers and everything. They didn't actually leak his entire tax return, but everyone saw the first page where his name was instead of their own. So it looked kind of bad for them, and there was a lot of fuss in the media. So you don't want to end up there. So set the correct headers, set cache expiry times and things like that, so you don't end up in that problem. Then there are what I've called promiscuous services. Those are basically services that either are showing too much or they allow others to touch their privates. What I mean by that is you might have a database object that has some data that you don't want exposed. Like you might have let's say a client, and that client has a client certificate or a client secret, and you don't want to leak that out. But if you're just like blindly mapping what's in the database over to XML and returning that back, you might end up in a situation where you're actually taking fields that are supposed to be kept secret on the server and exposing them out in the REST interface. And I've seen examples of that as well. And the second part there, you're exposing things out that are intended for reading by the client, but sometimes you forget that the client can also change those. So some of you might have seen Igor Homakov's hack on GitHub. The interesting part there is it says, Homakov opened this issue in 1001 years. So in the future. And he wrote there, hey, where's my suicide booth? A clear reference to Bender in Futurama. So the idea here was that he figured out that he could change data that he was not supposed to be able to change. So I'm going to show this. So here is like, you could have on a website, or it could be a REST service of some other kind as well, but I'm going to use a website here as an example. So I have this form where I can update my data. So if I do a get, I get my username, my first name, my last name, my email, and the date that this object was created in the database. And clearly, the last field here is not something that you're supposed to be able to change. So, what happens if I change that? So I want to say, well, maybe my user was created back in 2000 instead of 2013. And this is the response I get. So down here now it says 2000 instead of 2013. So I was not supposed to be able to change that field. It was provided back as a clear, a read-only field, but because there was no protection on the server to protect or to say which fields you could change, this can happen. So again, it's about exposing things out that you're not supposed to in the incorrect way. So this is really something you need to pay attention to. And a lot of these magic frameworks that just like transform things into XML and back and everything just works, and you're doing development and it goes really fast, and then suddenly you're in production and you forgot to think about this and someone is just hacking all your stuff. So don't go there. And then we have overconsumption, which is something that I think will only happen if you're using like a NoSQL database, which is document-based, or you're like storing XMLs directly into the database without doing anything with them. So you have like a small representation, a small XML that you're usually passing back and forth, and suddenly the client posts back a huge XML instead. So he's posting 100,000 fields instead of 5. And if you're not scripting those, if you're just like grabbing the XML, putting it in a database, or converting it to a document and storing it in a MongoDB database, you might end up with using a lot of more disk space than you wanted to. So you end up with something like this. And by the way, the MongoDB has a limit of 16 megabytes per document. So let's say the normal document is expected to be 4 kilobytes or something, and then you suddenly get 100,000 16 megabyte documents, then you quickly grow out of disk space. So that's something to think about. The next thing I'm going to talk about is what some people are doing is signing URIs. So the idea behind signing a URI is you can take URI and you can expose it out to a website, and then you will allow that website to download data that it normally wouldn't have access to. But because the URI is signed and it has an expiry and things like that, now it's the browser is able for a limited period of time to download that resource, like show an image or something like that. So and there are things that can go wrong there as well. So Taidong and Giuliano Russo, they discovered a flaw like this in Flickr's API signature way back, I guess it's 5 years ago or something like that now. What Flickr was doing was they would take the URL parameters that were supposed to be signed, and they would append, or prepend actually, a secret in front of them, and they would also strip out the and equal signs. So they would just sort it and mash it all together. And then they would do an MD5 of that and add that as a new parameter. And this is not the way to sign data. There's a reason why we have things like HMAC. And I don't think they understood what they were doing. Like, this seemed to work, and it was sort of hard to see how this could not work. But there are at least 2 problems with this approach. So let's look at what we're doing if we're doing an MD5 signature like this. So we have the blue part here is the data that we know. Those are the parameters that we were signing. And then there's the red part up front. That's the secret that we don't know. So we know that they're appending a secret of a given length and to our data, and then they're doing an MD5 of that. So the way MD5 works is that it splits this into blocks like this, and it has an S box that's static for MD5. and then it will run, it would pad the last block because that one wasn't long enough, so it would add some padding, and in the end it would add the length of the message. And then it would run the algorithm on that. So it goes like this, and you end up with the final result. The problem is you can do a length extension attack on this. So let's say we have the data that we had before, and we want to add something at the end. That's the red part at the end here. That's the attack. So what we're doing is we take the same data that we had up here. We don't know the red part, but we know the blue part. And we know what the padding would look like, because the padding is always calculated the same way as long as we know the length of the secret. So we can create a new set of data, which includes the old padding. So when MD5 comes along, as we know here, we were like doing this bit. And here we can skip that. We just pad, the MD5 algorithm will pad the last block, and then we skip the first one altogether. Because it's the same result up here and down here, because we included the original padding as data now. So the MD5 algorithm would do this, and then it would take the last bit here and eat that up as well. So now we have a new signature from the old signature without knowing the secret. We just added data to the end and run the algorithm over again, which is interesting. And because they were stripping out equals and signs, these two would be similar. Like here's B equals R2 BA set 3F01, and here is bar alic 2 baz alic 3, and etc. So these two would be treated the exact same way because it was stripping the characters out. So what you could do then was basically to add the padding to a parameter that wasn't used, and add your new parameters to the end and sign that. And you would have a valid signature for that data. You could length extend it. So again, here's an example. There's a signed URI down here, which I can use to get this exact comment. So the request I just did now was authenticated, but if I go to the next slide, or down here actually, I'm not doing authentication anymore. I'm just doing just getting that given URI without adding any sort of authentication. And we see, okay, I still get the same data back. So I was able to use the signed URI and get some data back. Cool. What happens if I change the ID from 0 to 1 and use the same signature? That should fail, because now the signature isn't valid anymore. So it says not authenticated. Okay, good. What if I then want to length extend the signature that I had? So I'm using double URL encoding here because I had to using that framework, but that might also be a problem in given web applications where they're actually doing double decoding. So in the original Flickr attack, you didn't have to do this, but there are a lot of null bytes here, for instance. So now I've actually created a new signature, and I've added ID is null in here as well, and I'm adding a new variable to the end. So if we look at the new URL, it says ID is 1, and then the signature, and then there's I equals D 0, and then the padding at the end here. So I've length extended the signature and added the padding. So now I can read another one without really having an authenticated URL for it. So over to implementing security. What should we do here? First of all, as I mentioned, with this problem with promiscuous services, you should have a contract layer. You should have a separate set of objects that define the contract you have with the clients. So those objects are sort of static. Those define the contract, and you can change everything behind those objects the way you want to. So this creates a nice abstraction. This creates like a layer up front, and you can do whatever you like behind there. You can change your data, you can do refactoring, you can do anything. And the good thing about this is now you know what fields you are exposing out to in the client. And also, when you're mapping between the actual objects and these contract objects, you know which fields you want the user to be able to change and which ones you don't want them to be able to change. So that's a really nice and a way of mitigating these attacks. And it's quite an easy thing to do as well. And yeah, it takes a bit longer time to implement, but once you got it up and running, there's not that much to it really. And it makes it also easier to do versioning because you just add a new version of these contract objects, and you can have the same objects internally that you used to. You can build reusable filters that you can add to your services, like a CSRF filter for doing CSRF if it's for a web service. Login filter, signature verification filter, and a filter that adds the correct caching headers so you avoid caching by mistake. And here's an example with Jersey in Java, where you can, on a class that's defining a sort of a base resource that all other resources or all other services are inheriting from, you can add the ones that you want to apply to all of them. So here I'm adding authenticated admin filter, a CSRF verification filter, a no cache response filter, and all services that inherit this base resource class, they will have these filters applied, which is effective because now I don't have to think about it every time I build a new service that, oh, I have to remember to add all these checks or all these filters. Now they're there by default and I have to turn them on, turn them off. So it's sort of a whitelisting approach instead of a blacklisting approach. And then you can test your REST security because a REST API is meant to be stable. Like if you're doing web development and you have a website and you're doing things with Selenium and things like that, things tend to break up very often. But a REST API is supposed to be stable because you're going to get clients and those clients are going to complain if you break your API. So the REST API is meant to be stable, and that makes it easy to test. So you can do actual integration tests where you're booting up an HTTP server and you're running requests against that API. And you can automate testing of CSRF protection, of signature tampering, logouts. On the project that I was on where I found this XSE attack, we implemented a test for testing against those attacks so they wouldn't reoccur at some later point in time if someone was messing around with the way that it was doing XML decoding or XML parsing. And then you can also check for data tampering, like sending in or changing fields that you're not supposed to and see what happens on the back end. You can verify the data, even go to the database and verify that the data was not changed. So you get a good automated security test suite that will really lock down your REST API and make sure you don't redo mistakes or even do mistakes to begin with. So that's it. I'll publish the code at GitHub, and there's my Twitter handle as well if you want to get in touch with me, and I have a blog. So that's it.